Okay, this video is for 8.4a, graphing cube root functions. So, in class this week we talked about many different things regarding graphing cube root functions. Some of those things are the domain, range, point of inflection, creating tables, and actually plotting the points from the tables to create the function. So that's what we want to look for on this worksheet and in some of these examples. To start off with that, let's do example 4. They've given us a graph, a few different dots on that graph, and they want us to identify the domain, the range, and the point of inflection. Just like yesterday with the square root graphs, the domain is going to focus on all x values, the range is going to focus on all y values, and the point of inflection is where the cube root graph bends. So let's start with that one. We can see that the cube root graph bends at this point here. And it looks like that point is the point -3, -1. So that is our point of inflection. Now, the domain of the cube root graph is all x values that it is possible to have. Is actually pretty nice. It's every single value. If you can see in the x direction, going to the right and going to the left of the point of inflection, that graph just continues on. Doesn't seem to stop, and outside of this window, it actually never does stop. So the domain is called all reals, and we write that with a symbol like this. It looks like an R with a second side, or a bolded side on the left side. All reals, so every single number is included in the domain. And the nice thing about the cube root function as well is that the range is the same way. It's a little harder to tell because it looks a little flat, but going down and going up with a cube root function, this graph will never stop, and so it will go from -infinity to positive infinity. So the range is all reals as well. Alright, now that we've done that, let's actually create a cube root graph. We'll work with problem number 6. First thing we want to do with problem 6 is fill out this table. Now, with the cube root graph, I'd say the easiest thing to do is fill out most of the table, but we don't have to quite do all of it. They've given us -8 and 8. Let's also find values for 1, 0, -1, 0, and 1. Alright, so if we were to plug these x values in for x in this equation, we would get the cube root of -8 plus 2. Well, the cube root of -8 is -2, and -2 plus 2 is 0. Now let's work with -1. The cube root of -1 is -1, plus 2 is +1. And then with 0, cube root of 0 is 0, plus 2 is 2. +1, cube root of +1 is 1, plus 2 is 3. And then finally with 8, cube root of 8 is 2, and 2 plus 2 is 4. So now we've got these 5 points, and we can graph this on our graph. -8, 0 is right there. -1, 1 is right here. 0, 2 is right here. 1, 3, and 8, 4. So our graph is going to look something like this. And it's going to continue in all directions, to the right and to the left in all directions, and up and down in all the directions. So the last thing to do for this example is to fill out domain, range, and point of inflection again. Well, our point of inflection is where this graph bends. That's going to be the center here of our graph. That is the point 0, 2. And just like in the previous example, the domain, the possible x values of this graph, extend forever in both directions. So our domain is all reals. Same with our range. It goes up and down forever in both directions. So our range is, once again, all reals.